So, teacher fail here. I forgot to put these in before we copied. Sorry. There are worse typos that there could be, though. We can survive those. And then also on number 4. Number 4. Okay. Now my XY tables are drawn in. All right. So, graph the function, state the end behavior. I personally think that these two problems take the longest time. The rest of the stuff tends to go pretty quickly. These two take the longest. I do notice that I have a 0.25, so I'm going to be dealing with decimals. If they give me decimals in the problem, I can use decimals in my stuff over here. Let's see. So what form is this equation written in? It's written in intercept form. Okay? Which means that what are my X-intercepts? I have one here, right? What is that one? -1. Now, when I'm looking just for the X-intercepts, you don't really need to put the multiplicity. You'll show me the multiplicity through the way that looks when I graph it. Does that make sense? You can if you want to. But if you write it wrong, then I have to mark you down. So, all right. And then this one, what's my intercept here? +3, because we changed those signs. Now, when you get this line here that says X-intercepts, there are two different ways you could write your answer. You could do it the easy way, which is just that. Do not put parentheses around it, though, because what happens if you put parentheses around it? It's a point -1, 3, which is not an X-intercept. It's something up here. So do not put parentheses. The other way you could write it is if you wanted to write it in ordered pair form, you would write -1, 0 and 3, 0. That's the other way you could write it. Okay? That's all I'm looking for is just the X-intercepts. I had someone come up to me yesterday and say, Mrs. Franken, what do you mean by X-intercepts? I don't know how to define that more clearly. I mean X-intercepts. Okay? So, couple questions. First off, what is the degree of this particular... Actually, let me step back. What is the leading coefficient? Is it positive or negative? Which means what? The right side is going up. So from here, further to the right, it's going to be going up. Now, at that particular point, what kind of intercept is this? Is this one a kiss, a cross, or an inflection point?
Inflection point.
This one is an inflection point. So if it's going to end up going up, I'm going to draw my inflection point in like that. So that way I know what's going on. Okay, that way I don't have to worry about making that inflection point match what I've drawn before. Now, most people struggle with drawing an inflection point. I'm fairly lenient, but it better not look like a cross. It better look like you at least attempted some kind of an inflection point there. All right? Okay. The leading coefficient was positive, so the right side goes up. Yes. It's not so much a hump. It's like it comes up and it flattens out and then it goes up again. Okay? Good clarification. So not so much like that, more like this. Because what happens is when people do this, the really exaggerated ones like we did before, they end up making several more X-intercepts that don't exist. Because it can only technically cross through at that point. All right? What's the degree? Is it even or odd? Because I need to know what's going on the left side. Odd, how do you get that? 1, 2, 3, 4, 5? So what does that mean about this side? The left side. It's going the opposite of the right side, correct? That's what odd means. So that means it's got to be going down. Now, what kind of intercept is this? Is it going to come from the bottom and cross through? Is it going to kiss it, or is it going to have another inflection point? It's going to kiss it because it's a degree of 2. Now, don't draw your kiss coming in from over here. Usually they tend to go straight down for the most part. And I'm just going to curve that over a little bit because I'm going to do some work in here. But it should go fairly steep down, not crossing your -2 line because you don't know anything. Now, what's my XY chart for? What do I need to find out in here? Now, several people just put 1 on their XY chart because 1 is straight in the middle. But what did I say when you have multiple grid lines between your zeros? Do all of them. So 0, 1, and 2 are all points that I want to see on your XY table. Does that make sense?
Yes, ma'am.
So, to save a little time, when you plug in 1, you get -8. When you plug in 0, you get -6.75. And when you plug in 2, you get -2.25. You can check those on your own time on your calculator. So let me plot these. 0, -6.75 is like down there. 1, -8 would be down there. And 2, -2.25 would be right around there. So now I need to make all this fit in here. So it's going to go down like that. And then this one is going to have to connect with my inflection point, something like that. Okay? Kind of sort of makes sense? Okay. Several people had end behavior going weird. Let's fill in the end behavior. X arrow infinity, what side of the graph is that asking about? The right side. And the right side is going up. This one's asking about the left side, and what's happening to the left side?
Down.
It's going down. We good there? Next problemo. All right, what are my X-intercepts? I have an X-intercept here, don't I? There's an X there, which means there's an X-intercept. A lot of people missed that one. What is that one? 0. What do I get from here? -1, and from here? +2. Right? So let's see, 0, -1, and +2. Now most people figured out you needed 1 on your XY chart because they wanted to know what was going on between those two zeros. But you also need to know what's going on between these two zeros. So what other value should I put in my XY chart? What's between 0 and -1? I need both of those in my XY chart. A lot of you had like 6 or 7 values there. That's great. I'm only looking for those 2. Okay? You're not getting credit for the other ones. All right, let's talk end behavior and types of crossings. I have a negative leading coefficient. What does that tell me about the end behavior on the right? It's going where? Negative leading coefficient. Down on the right. All right. What kind of intercept is at +2? A kiss, a cross, or an inflection? A kiss. So it's going to bounce back somehow. Okay, just filling that in to guide myself. The other intercepts are all what? The other 2 are both crosses. What's the degree? 1, 2, 3, 4. So what does that mean about the left side? It's also going down. So let's see. If this one's going to cross, it's going to go up somewhere. So I'm going to need to find out how high it goes right there. And then it's going to have to come back down and cross here, right? And it'll come down some amount there. When I plug these in, does anyone know what I get? 1, I get -4. Anyone know 0.5 or -0.5? 3.125. So let's see, -0.5, 3.125. Goes all the way up to there. A lot of people just drew a straight line there because they didn't put -0.5. That was weird. And then 1, -4, so this one's going to come all the way down to here. And that's what my graph looks like. As far as end behavior, both are going towards -infinity. Yes?
For the test, are we going to have any that we have to plug in, like a
Possibly.
Thank you.
Because what happens is when you have zeros that are so far apart like this one, they tend to get really, really low. So when you start plugging in ones in between, you end up getting like negative 54, and we don't want you to have to graph that. So we tend to have to pick zeros that are a little bit closer in order to get something you can actually fit on your graph. Okay? All right. Next page. By the way, those were 6 points each. All right. Write a function in intercept form. So the first thing I need to know is, what are my intercepts? I see an intercept there at -1. And that one is a inflection point, isn't it? And I see an intercept at 1, and that is just a cross. And I see an intercept at 2, and that is a kiss. Yes? So, if I have an intercept at -1, that's going to look like x plus 1. And since it's an inflection, it's going to be to the third. Intercept of 1 is going to look like x minus 1, and a cross means it just has no exponent. It has an exponent of 1. And then finally at 2, that's going to look like x minus 2, and a kiss means it's got to be to the second power. Was that terribly difficult? Now it says include a constant term of a equals 1 or a equals -1 based on the end behavior. Based on the end behavior in this picture, what does my leading coefficient need to be? -1. So just throw a negative there and you're good to go. That's all it means. We good there? Okay. This is the other graphing problem, and a lot of people forgot about how to graph cubics, but we did do graphing cubics before we did the rest of the polynomials. And I'm actually going to make this a little bit longer, because I think I'm going to need a little more space, because the first thing you need to do is you need to identify your inflection point. What's your inflection point? -3, 1. If my inflection point is -3, 1, where do I put that on my XY table? In the middle. I do expect to see 5 points on your table. If you look at my answer key, I have 5 points listed for your XY table because I want to see that you were plugging in stuff the way you were supposed to. So of the 7 points, we've got 5 for your table, 2 for the graph. Okay? Because if your table's wrong, your graph's going to be wrong. The table is really where it's important. So what do I do around -3? I need to see values around there. So I'm going to do -4 and -5. And also -2 and -1. So this is the one where I need 5 full points. The first page, the ones where it's in intercept form, those are the ones where I just need to know what's going on between the zeros. Okay? All right, so what am I going to do with these x values now? Plug them into my equation right here. All right? -5 plus 3 is -2. -2 cubed is -8. Times 1/2 is -4. Plus 1 is -3. All right? I'm going to save some time. You can plug the rest of them into your calculator if you want to check me. But that one you get 0.5. Here you get 1.5. And here you get 5. If I've got all those right, all I have to do is plot points and connect the dots. -5, -3, -4, 0.5, -3, 1, -2, 0.5, I'm sorry, 1.5, and -1, 5. And that's what my graph should look like. So? Out of curiosity, could you describe from this what's going on? What does the 1/2 mean? You have a, what kind of compression? A vertical compression of 1/2. What have you got going on here? shift to the left 3, and here,
Up 1.
up 1. Okay? Because that leads us into these problems.
Yeah.
These ones go quick too. If you have something that is translated right 5, that means you have an H value of positive 5. By the way, does it tell me what type of equation I'm looking at? Does it tell me it's a cubic or anything? It doesn't, does it? It says, write it in terms of the original f of x. Do you see the f? We have to have the f there on these guys. No f, you lose a point every time. Okay? So, translated right 5, g of x equals f of x minus 5 is what that's going to look like. An h value of positive 5 looks like a negative 5, and it's got to be in the parentheses with the x. All right, what's going on here? This is another h value. What's the h value here? It's a positive 3 in here, which means it's a negative 3. So what do I have? Translated, or you can write shift. I'll accept either. Left 3. Do not just say shift left or translated left. Tell me how far it has been translated. All right, compressed vertically by 3/4. That is an a value, which means that the 3/4 must come before the f of x. So? All right, I've got a negative right there. What does that mean? Vertical reflection. Some people write what the reflection is across. If you want to write it is across something, you would say it is across which axis? Your brain thinks y because it's a vertical reflection, but a vertical reflection goes from top to bottom, which means it's crossing over the x-axis. It's following the y-axis. Yes?
If I say reflected, it's still right.
Yes. Yes. All right, stretched vertically by 4. What does that mean 4 is? Is it an A, an H, or a K? That is an A value. So I have 4f of x. And then translated 2 units down, what is that? That is a K value. K does not go in the parentheses with the x. It goes after, and that's what it should look like. Okay? So? So here we go, last page. Select true or false for each statement. So, looking at this graph, I would in my head or even on my paper draw a little sketch. I have an even degree and a positive leading coefficient. What does the positive leading coefficient tell me?
It's a positive.
Right side goes up. What does the even coefficient tell me about the left side? Both sides go up and there's a bunch of wiggles. Yeah? So I need that in mind as I'm doing this. True or false? The range is negative infinity to positive infinity, meaning all real numbers, right? That's what that means. Is the range all real numbers? No, because it has a bottom part, doesn't it? It has a place where it stops, so that's false. All right. B, as x approaches negative infinity, what side of the graph is that asking about? The left side. Y is going down. Is y going down on the left side? Nope. The domain of the function is negative infinity is less than x is less than infinity. That's another way of writing all real numbers. Is the domain all real numbers?
Yes.
Yes. The domain for any graph, odd or even, is all real numbers. Okay? And then this one, as x approaches infinity, meaning on the what side?
Right.
The right side, y is going down. False. Because on the right side it's going up. So false, false, true, false. Okay? All right, sketch a graph of this one. No need for x and y axis. I'm just wanting ends and bends. So, Negative leading coefficient. What does that tell me about the right side? Down. Even degree. What does that tell me about the left side? Also going down. It's a fourth degree. By the way, this is 1 point, 2 points. The third point comes in with how many bends you have. You have a fourth degree, so how many bends? That's what your graph should look like. Questions there? A lot of these questions go really fast, don't they? Fast, fast. These guys should be fast. This page was mostly fast. All right. I have a graph. What can you tell me about the leading coefficient? Why? Right side's going up. The degree, is it odd or even? How do you know? Go in the opposite directions, up and down, the end behavior. I see 2 bends, so what would I say about least degree? Third. Again, do not circle odd and tell me 2 as the degree. That doesn't work. End behavior, X arrow infinity, that's asking about the right side is going up. This one's asking about the left side, it's going down. Domain? Range? Easy peasy. All right. Leading coefficient here. How do you know? Right side's going up. Degree. How do you know? Both are going the same direction. Least degree. 1, 2, 3. Which means what? Fourth. Again, don't circle even and tell me third. Those don't work. End behavior. Both ends are going up. What's my domain? All real numbers. And what is my estimated range? Y is greater than or equal to -3 because everything is above -3. We good? All right. Leading coefficient, positive or negative? Negative. How do I know? Right side's going down. Degree, odd or even? Odd. Why? Other end's going the opposite way. Least degree. This is where people struggled a little bit. I see 1, 2, 3, 4. I could say a 5th degree, or you could even say, yeah, let's stick with 5th degree. You could argue a 7th degree. I'd probably give you credit for that also, because there's more going on here, because that's not just clean bend. But 5th degree is the most obvious. All right, end behavior, X arrow infinity. That's asking about the right side. Right side is going towards negative infinity. Left side is going towards positive infinity. Domain? Range? All right, down to the last question. A cubic function is graphed. That statement right there tells me that instead of doing something like this with the f's in it, I'm taking the f out and I'm replacing it with what? A cubed. So no f in your answer here. Write a cubic function using the given reference points. Okay, so here's the original. The original always goes through the origin. And my new inflection point is right here. What are the coordinates of my new inflection point? 4, 1. That's my h and my k value. So I know I'm going to have x, that's a positive 4. It's going to look like -4 cubed, and then my plus 1. I just need to figure out the a value now. How do I figure out the a value? Do the box thing, remember? This is a 1 by 1 box, always on the original one. What's my box here? 3 by 1. Which makes a 3. Is it a positive 3 or is it a negative 3? Positive. Why? Because it wasn't reflected. Right side's still going up just like the original. Left side's still going down just like the original. If it was reversed, then I know that a value would be negative. But that's the answer to that guy right there. By the way, this one was not worth 3 points. It was worth 4 points. I apologize for that, but if I didn't make it worth 4 points, it added up to 49, and that was bothering me. I had to throw in an extra point somewhere. Okay? Yes, question?
So if you were to leave the F, does it change the entire equation?
If you were to leave the F, I would take off a point. Uh-huh. Because the F gets replaced with the cubed right there. You know what kind of function it is, so put the cubed. The F you use when you don't know what kind of function you're graphing. Okay? Any other questions? All right. Happy studying.